Right then, lesson today, trial and improvement. So it's time for you to make some notes. Heading, lesson objective, keywords, dates in Welsh. Okay, note the keywords, comment, decimal place, guess, and trial and improvement. Okay, that's educated guess we're talking about now. So hit pause, and when you're ready to have a look at the starter, hit play again. Right, so our starter today, first starter, we got water from a cuboid with capacity 2 litres poured into a cylinder of radius 3 centimetres. What's the height of the water in the cylinder? Okay, so how high does 2 litres go in this cylinder? In order to do this question, you have to know that 1 litre, which I'm sure you do, is equal to 1000 cubic centimetres. That means 2 litres is going to be equal to 2000 cubic centimetres. So that's the volume of water we have in the cylinder. Now, we know the volume of a cylinder. In this case, it's got a radius of 3 centimeters. We know and we're looking for the height. Let's just draw it in. So we're looking for the height. It might not be full, but we know it's up to 2 litres. So volume of cylinder is the area of the front face, pi r squared, times the height, h. Now we know that the volume, pi r squared h, is equal to 2000, because that's how much is being poured into the cylinder. R is 3, so pi times 3 squared times h equals 2000. 3 squared is 9, so 9 pi h equals 2000. And then to get the h on its own, the 9 and the pi go down under the 2000, so h is equal to 2000 divided by 9 pi. And that's our solution in terms of pi. Okay, you still got pi in the solution there. That's what they wanted in terms of pi. We can't simplify any further because 9 doesn't go into 2000, so this is the best way to leave this question. Question 2. A pack of 9 toilet rolls costs £3.96 and a pack of 4 toilet rolls costs £1.84. It's quite a topical question. Just before COVID, they were you couldn't buy these in the supermarket. So we have 9 toilet rolls. They cost £3.96. One roll will cost, £3.96 divided by 9. So 3.96 over 9, right, like that. I'm just going to do the calculation here in the margin. 3.96 divided by 9. 9 can't go into 3. Decimal, carry the 3. 9 into 39 is 4 times, remainder 3. 9 into 36 is 4 times. So that's going to be equal to 0.44 or 44 pence. With a four roll pack, 4 rolls cost £1.84. So 1 roll, same technique, will cost £1.84 divided by 4. Oops, there. So if we do our workings here, 1.84 divided by 4. 4 doesn't go into 1, so we carry the 1, don't forget the decimal. 4 into 18 is 4 times, remainder 2, and 4 into 24 is 6 times. So that's 0.46 or 46 pence per roll. Per roll. So that means the 9 pack is the best value for money. Okay? In these questions, you make sure you state which is best value. Good. If you got them right, tick with green pen. Made any errors, then use your green pen to write your corrections then in full, not just the answer. So hit pause, carry on with that. When you're ready to move on, hit play again. Okay, so we move on. Okay, so what we're going to do here is we're going to use trial and improvement to estimate some answers. Okay, will give us a reasonable approximation. When we've been solving equations in the past, we've had whole number solutions or integer solutions. So if you have x squared plus x equals 6, you can substitute the 2 or the minus 3. If we had substituted a 2, you would have, let's just write that on here quickly, 2 squared plus 2. 2 squared is 4 plus 2 is equal to 6. So these whole number solutions work. You could put the x equals 0 in this one, so that would be 0 cubed plus 2 times 0, which is also 0. So the whole number solutions work for these first three. With these ones, because we got these decimals, then we're going to approximate the answer, and we're going to use what's called trial and improvement. Okay? It's otherwise known as an educated guess. It's not a guess in maths. We can call it an educated guess. Trial and improvement. So that's the technique we're going to use. So here's our first example. We've got to solve x squared minus x equals 27. You can use a calculator for this exercise. Okay? And we've got to solve it to 1 decimal place. That's very significant. So we've got to find a technique to use to get this to 1 decimal place. So what we do is we create a table. So we have a table like that, where we have x, which is our estimate, our guess. And then this is our equation, x squared minus x equals 27. And then we have a comment column. I'm going to show you how we use that. So in the first instance, say we guessed that 5 was a good place to start. So we'd say that x equals 5. Now we substitute that into this equation here. So wherever we see x, we put a 5. So it's 5 squared minus 5. Okay, we work that out. 5 squared is 25 minus 5, and the answer is 20. That's smaller than 27, so that's too small. And it's that simple. 5 is too small, so I'm going to try something bigger than 5. I'm going to try 6. So 6 squared minus 6. 6 squared is 36, minus 6 gives me 30. Now that's too big. So now I know my solution is going to be between 5 and 6, because 5 is too small and 6 is too big. So I'm going to go right in the middle of them, 5.5. Put that in here, 5.5 squared minus 5.5 is equal to, and I can plug that in my calculator, and you should be getting 24.75. So I want you to try that in your calculator now. Just make sure you can get 24.75. Now when I compare 24.75 with 27, I can see straight away it's too small. So I need to try a number that's bigger than that. I'm going to try 5.6 because I like to go methodically. So 5.6 squared minus 5.6. Plug it into my calculator, I get 25.76, which is again too small. So if 5.6 is too small, I'm going to try 5.7. 5.7 squared minus 5.7, and that gives me 26.79. It's close, but it's still too small. And then I try 5.8, which I think is going to be over. So 5.8 squared minus 5.8 is equal to, plug into my calculator, and that gives me 27.84. Now that's bigger than 27, so that's too big. Now that tells me straight away that my solution is going to lie between those two numbers. It's going to be between 5.7 and 5.8. The question is to one decimal place. So which one is it closer to? 5.7 or 5.8? To do that, I put another sketch at the end of my work here. And it's a number line going from 5.7 to 5.8. And I test halfway in between them, which is 5.75. So I test 5.75 and I got 5.75 squared minus 5.75. Plug it into my calculator and that is 27.3125, which is too big. So that means 5.75 is too big, which means I'm going to have to try something smaller than 5.75, which means my answer is going to be closer to 5.7, which is the answer I'm going to select. So the answer is equal to 5.7, or we say x equals 5.7. Okay. Now, this is the technique you have to follow. You have to follow this step by step. You don't get any marks in the exam. One thing students like to do with this is when they get the calculator, they start plugging in numbers in, and they say, "Oh, I can get it to closer and closer, 5.728, and so on." But that's not the question. The question is, use this technique to work out the solution to one decimal place, and then stop there. Okay, good. So make some notes on that. Draw the table, make some notes, and if it was a 4-mark question, you get 1 mark for drawing this sketch at the end. So make sure you draw that, and we'll have a go at the next question then. So hit pause, make some notes, hit play when you are ready to have a look at the next one. Okay, so moving on. Oh, we've just done this one. Right, example number 2. Solve x cubed plus 2x equals 6. Again, to one decimal place. Make sure you note how many decimal places you're going to work your question to. Okay, so again, we sketch our table. We got our x term, which we're going to guess. You got x cubed plus 2x equals 6, and then our comment. So we always set it up like that, and we always work through it like that. In this case, it's only up to 6, so it's a small number. I'm going to try 1. Okay, so I'm going to try 1, and when I try 1, I get 1 cubed plus 2 times 1, and that gives me 3. Too small. 1's too small. So logically, I'm going to try 2. 2 cubed plus 2 times 2. If I work that out, that's 8 plus 4 is 12. Too big. That's great for me because now I know my answer is going to lie between 1 and 2. So I always like trying 1.5. So I do 1.5 cubed plus 2 times 1.5. Plug it into my calculator, and that gives me 6.375. Close, but it's too big. So 1.5 is too big, so I've got to go down the size. 1.4. 1.4 cubed plus 2 times 1.4 is equal to 5.544. That's smaller than 6, so my solution is too small. Great. So that tells me then my solution is going to lie between 1.5 and 1.4. So I draw my number line. The bottom of the page, 1.4, 1.5. Halfway between them is 1.45. So I'm going to check if 1.45, if it's too big or too small. 1.45 cubed plus 2 times 1.45. Plug that in my calculator, and it gives me 5.948, which is too small. So 1.45 is giving me an answer that's too small, which means I'm going to try something bigger than 1.45, which takes me towards 1.5. So my answer is equal to 1.5 to 1 decimal place. Okay, x equals 1.5. So again, make some notes, sketch the table, and when you're ready to have a look at the next question, hit play again. Okay, third example for 1 decimal place. We've got a rectangle, and a rectangle has got a length x plus 3 and a width of x, and they say the area is 52, but they haven't given me an equation, so I need to form my own equation in the first instance. How can I do that? What's the area of a rectangle? Is equal to length times width. So what we have here then is length times width is equal to 52. The length is x plus 3 and the width is x. So we can say x times x plus 3 equals 52. And when we expand that out, we get x squared plus 3x equals 52. So we've now got an equation, and we need to use trial and improvement then to solve for x. This is more typical of a type of question you'd get in an exam. Okay. So we've got our table, and if we start to try some numbers then, I'm going to start with 5. If I put 5 in here, 5 squared plus 3 times 5 is equal to 25 plus 15 is only 40. Smaller than 52, so my comment, too small. Then I try 6. 6 squared plus 3 times 6 is equal to 36 plus 18, 54. Too big. So one's too big and one's too small. So I'm going to try something in between. Now, to cut it short for this third equation, because I think you have a method, I'm going to try 5.8. Okay, 5.8 squared plus 3 times 5.8 is equal to 51.04. It's close, but it's too small. So I'm going to try 5.9 now. 5.9 squared plus 3 times 5.9, work that through my calculator, gives me 52.51. That's too big. Now I know my solution is going to lie in between those two. So I'll put my number line here at the bottom. It's 5.8 to 5.9. And I'm going to test 5.85. So you try 5.85 in our equation. 5.85 squared plus 3 times 5.85. Work that through my calculator and it gives me 51.7725. Smaller than 52, so too small. So 5.85 is too small, which means I'm going to try something bigger than that. So I'm going to travel towards 5.9, which gives me my answer. So x is equal to 5.9. Okay, so make some notes, and then I've got a couple of questions for you to try. Try those, and then we'll have a look. As soon as we finish that, we're going to have a look at trying 2 decimal places next. Okay, so pause, make some notes, and when you're ready to try some questions, hit play again. Good. So we've got 5 questions for you to try. So hit pause and have a go. And when you're ready to have a look at the solutions, hit play again. And once you've done that, we've got one more example for you. We're going to look at 2 decimal places then. So try that first, and then we'll look at the example after that. So hit pause and hit play when you're ready to check the answers. Okay, so for question 1, you should have 2.4, for 2, 5.7, for 3, 1.8, question 4, 3.6, and for question 5, you should have 2.1. So mark your work, and then we're going to have a look at 2 decimal places next. Okay, so when we want to work to 2 decimal places, we have a similar sort of problem. Now this is the question we worked through earlier on the rectangle. This time though, we're going to be considering our solutions to 2 decimal places. So we got 5.9 and 5.8, and we know it lies in between them. Okay, so what we do is we need to find solutions between 5.9 and 5.8. So if we try 5.86, which has 2 decimal places, and we put it in our equation, we get 51.9196, which is smaller than 52, so it's too small. So if 5.86 is too small, we've got to try something bigger than 5.86. We try 5.87. When we plug 5.87 in, it gives us a number that's bigger than 52. So it's too big. So our solution lies between 5.86 and 5.87. So because it's in between those two, then we try 5.865. Okay? So we work on 5.865. We have our number line at the bottom here. This time it goes from 5.86 to 5.87, and halfway is 5.865. 5.865 is too small, so that means we're going to try something bigger, and we're going to go towards that answer there. So x is equal to 5.87 to 2 decimal places. So you might want to make some notes now. And when you're ready, I've got a few more questions for you. There you go. So these questions, I want you to work them out to 2 decimal places. When you're ready to go through them, the solutions, hit play again. Okay. So for question 1, you should have 3.41 to 2 decimal places, 4.71 for 2, 5.21 for 3, 1.27 for question 4, and 2.39 for question 5. Good. To round off, I'll give you a few questions now. And some questions for you. Work from question number 5 to question 11. Good luck. I'm going to place these questions in your assignment as well.